Hello guys, welcome back to another exciting video in our series on working with agentic AI systems. So in today's video, we're going to go ahead and cover something that's really kind of like a buzzword in AI at the moment. So it's basically MCP. You've probably heard of MCP servers, MCP clients, and all this MCP being thrown around. So in this video, I want us to talk about MCP. So it was originally not part of the course of the course outline which I planned, but it's really I have experimented with it, and I think it's going to be something of importance in the future. If not even that, is having this tool in your toolkit is going to be very instrumental, right? Because I will explain to you why, and throughout this video you will understand why having this in your toolbox is going to be very important. So I decided to put away the video on working with basically working with basically a human in the loop, and then right, instead of working with human in the loop, you are going to be looking at MCP architecture or MCP servers in this video. Okay, so in the last video we talked about how to work with memory, show how to make short memory more persistent by storing the short-term memory within a more persistent layer, basically SQLite, simple as a SQLite database, right? So yeah, so in this video, we're going to go ahead and talk about what's MCP. Why do you need MCP? The general architecture of MCPs, MCP. So MCP stands for Model Context Protocol. Okay, so it was introduced by Anthropic, and it was somewhere around last year November. It was introduced, but it was not really that much of in use until recently. It became more and more relevant. So let's go ahead and we'll learn how to write our own simple MCP server in Python. You can also do it in JavaScript, I believe. We're also going to go ahead and build a LangChain agent that's going to be connecting to our MCP client, our MCP server, sorry. And you're going to do things like streaming and see how all that works. Okay. Okay. So this is what I've done last time, right? Last time we looked into memory and how to make short-term memory more persistent using an SQLite database. So in this video, we're going to jump into what is MCP, right? So MCP stands for Model Context Protocol. So basically, it's just a way that we can provide context to our different LLMs. So this is what, let me just go to the official documentation, which is just a model context protocol. You can go to modelcontextprotocol.io, and in the introduction section, let me just give you the way they stated MCP, or the way they said MCP is in their own words. So they say that MCP, which is right, I'm reading from right here. So MCP is open protocol that standardizes how applications provide context to LLMs. That's basically it. So model, right? The model part, LLMs, right? And then we have the context. So how we provide this context to these LLMs is what MCP is, right? And then the protocol it follows is what the whole MCP comes for. So you can think of MCP, this is what they said. You can think of MCP like a USB port, right? A USB port for AI applications. Just as USB-C provides a standardized way to connect your devices to various peripherals and accessories, MCP provides a standardized way to connect AI models to different data sources. So what does it mean? Okay, let me explain to you this in the very simple context using a diagram. Okay, okay, I hope it's simple, right? Okay, so you let me know in the comment section whether it was simple or not. So basically, this is the problem that we have at the moment, right? We are all creating our agents, and the agents are sitting on top of different LLMs. And this, every programmer has their own way of writing, their own tools, their own way of designing their agentic systems and how tools work and all that. Right? There's no fixed standard way of doing things. So let's say that today I'm using LLM-A, right? And I write my tools in a different architecture that LLM-A supports. And then tomorrow someone says, you know what, I want to use the same agent, but I want to use a different LLM. Let's say LLM-B, right? So LLM-B supports a different way of interacting with tools. Then again, I have to go ahead and rewrite my tools again from scratch. So this is going to be my emailing tool, my database tool, my vector database. I have to write them again from scratch, right? So this was the original one. Then I have to write it again, just to work with LLM-B, right? So that's the problem that we currently have at the moment. So right, some tools work well with certain LLMs, and then or basically language models or AI models, and then don't work very well with other models, right? Other language AI models. So this is becoming a problem, right? And every programmer has their own way of writing different tools. So they have their own way of defining things. Every system has their own way of going about things, right? So there's no standard way. So that's what MCP, or Model Context Protocol, tries to address. Let's have a standard way. Just like we have a USB-C port, right? If you buy any PC in the world, you can connect a USB-C port to it. Okay, let's with the exception of MacBooks, right? I don't know. Yeah, they have a kind of a different way from my knowledge. I never owned a MacBook. I'm a more of a PC guy, right? So MacBook have, I think they have a different way of, they don't even have USB-C ports, right? So let's have a one standard way of connecting our tools to our agents, right? So let's have a standard way of doing that so that you don't have to, everyone doesn't have to come up with their own standards or their own way of different doing things. And then if you want to move from one tool to another or from one LLM to another, then you have to go ahead and rewrite a lot of bunch of code, right? So let's have one standard way of doing things, and that's where MCPs come into play, right? Okay, so how does MCP really address this challenge? So let's say that we have one agent right here, right? So let's say that we want to connect our agent to use LLM-A, right? So to using LLM-A, we don't have to actually redefine or rewrite these tools right here. So the email tool, the database tool, and the vector DB tool, they don't have to be rewritten in order to work with our LLM-A or LLM-B in order to for this agent to use them. So this is how do we go about achieving that basically, and that is where MCP servers come in. So MCP server, they sit in between the LLM and the different tools. So our LLMs interact with these MCPs servers, or basically our agents interact with this MCP server, because our agent basically interacts with, I have the LLM here just to make it more verbose, because the agents interact with this, right? Agents interact with LLM, and then the LLM can interact with this, right? So you can think of it like that. So that's basically, so now we have the LLM, the agent right here. We can have the same agent, and we want to use different LLMs that have different ways of dealing with tools. So we can just, instead of having to write our tools in different ways, and then having write our tools in different way that suits these different LLMs, we just write our tools in one way, following one specific standard or protocol, and we provide an API server that these LLMs can interact with, or a bunch of tools that this LLM can interact with. That's basically the whole idea of MCPs, right? So MCPs introduce another layer, right? So instead of having just this, right, we have another layer sitting between the LLM and the tools, right? So the agent is not directly interacting with the tools, but is interacting with the tools through the MCP server, which defines a set of standards, right? So once your agents follow these standards, then you can interact with any MCP servers in the world, right? And that's really awesome. So that's basically, so this is basically where MCP servers sit in between the different agents and the tools. So defining the protocols that we agents can use to interact with these tools, right? So why do we need MCPs, right? Why MCPs? What's the whole point of MCPs, right? Okay, let's look at some of the advantages of MCP. So MCPs provide you the ability to use any LLM of your choice. So back to this image, you can see you can use either LLM-A or the LLM-B. It will still work. You don't have to go ahead and rewrite your own tools, because once your agent follows the protocols of interacting with these MCP servers, then you can interact with any tool that is under or behind an MCP server, right? So you can interact, you can use multiple LLM and LLM providers. You can use OpenAI, you can use Anthropic, you can use DeepSeek, okay? If you're supposed to calling in the future. At the moment, I don't think it's supposed to calling. The last time I tried, at least, right? So it also provides a standard of using tools, or basically APIs, right? Just like the way they use the USB-C example in this case, it standardizes everything. It comes with a bunch of standards, and as long as your agents follow these standards, then they can interact with any MCP servers in the world. And MCP servers in the world can have a bunch of tools sitting below these MCP servers. So let me just show you an example right here. So you can see right here, this is this website called Smith Theory. I hope that's the right pronunciation. So on Smith Theory, we have a bunch of tools that we have here. We have tools to interact with GitHub, tools to interact with Brave to search the internet, tools to interact with V0 for front-end developers. And you can see, we have a bunch of tools right here. So if you have, as I said here, you can extend your AI agents to use over 1,364 tools. Like, that's insane, right? So you can, instead of having to write all these tools yourself, you can simply go ahead and interact with these MCP servers, and then save yourself a ton of headache, right? So because some of the things are just like redundant, like writing them yourself is just redundant. If someone has already done it, why would I want to waste my time doing it from scratch? It doesn't make any sense, right? So if I want to interact with a CLI, I have a tool for that. If I want to interact with Notion, I have a tool for that. If I want to interact with my Google Drive, I have a tool for that. If I want to interact with uh, Brave Search, I have a tool for that. If I want to interact with GitHub, I have a tool for that. I have a tool for a lot of things, right? So all these tools are written by other people. You can also write the tools yourself, and I'll show you how to write one in this video, right? So you can write your own tools, and your LMs can simply connect to these tools instead of having to spend hours and hours writing your own custom tools, right? So they all follow a set of protocols or standards that is provided by the MCP protocol. So once your agents or your agent framework or architecture follows this protocol, then you can interact with any of these tools on the internet that support MCP. So there are just so many limited opportunities that you can currently use. So it also supports the best practices, like these tools are written by people and they try to implement the best practices, hopefully, right? So I am not sure, I can't really guarantee you on that, but yeah. And then we also have a lot of inbuilt integration. So you can see right here, we have a lot of integration that you can simply just get in and then plug into your agentic systems and begin to work with them. You don't have to spend weeks and months trying to code things from scratch, right? So that's one of the powerful advantages of MCP. So we move from having to write custom things, kind of fine tune things for different LLMs or for different agents, and then once you introduce another different LLM, things break, right? So we have one standard way of doing things, and that's where the MCP layer comes into play. So we have the agent layer, the large language models layer. We have this all part of one thing, right? And then we have the MCP layer, and then we have the tools layer, which are basically under the MCP. So we have a bunch of things that you can use. Okay, so let's look at the general architecture of an MCP server. So basically, we have a host, and the host could be like your agent, your different tools, right? So sorry, this could be like, when I mean tools, I mean like agents can use these tools to do different things, right? So we have the host right here, and this could be something like we can say the cloud desktop application. You can think of that as a tool. That is really not a tool, but yeah, that's basically it. So we have the host right there sitting on top of it. Then underneath we have a bunch of MCP servers. So we have server A, server B, server C, and all of this can connect with different things, right? So you can have an MCP server for local Postgres. We have an MCP server for file systems. You have an MCP server for interacting with a remote host like Postgres databases and stuff like that. So all these are just so the agent can interact with all these MCP servers through the MCP protocol, right? And the MCP below the MCP protocols. Sorry for this type right here. Below the MCP protocols, we have these different tools that sit underneath this MCP protocol. So you can have your own virtual environment right here, and you can connect with external tools. Like this could be the internet, Postgres database, or any other thing that's outside of your network, right? So you can connect with it like that. So that's basically given the simple architecture diagram that I drew myself. Okay, so looking at the diagram, we have things called MCP hosts. So what are the hosts, right? So this is basically what the host. Let me just go back to this. Basically, the host. This could be an AI agent, the cloud desktop application and stuff like that, right? So we have all those, right? We have the clients, basically anything that interact directly with the MCP server. We have the MCP servers themselves, and then we have the local data storage, like the file systems, the local Postgres, local MySQLs. All those are local data sources. We also have remote services like the internet. For example, if you use the Brave search tool, it's going to be using the internet for searching things online, right? We also have the remote servers, remote services. That's basically what the remote, everything that's outside of your, kind of like the computer or your network, right? You can, I assume that's remote. Okay. Okay. Now that you have looked into that, let's go on to creating our own MCP server, right? So let's jump in and get our hands dirty. And again, I'm going to be following all the instructions. Just a second. I'm going to be following all these instructions right here. So if you go in here, you can just go in here and click on server developer, and then you can follow all the instructions on how to build your own MCP server, right? So we're going to be using this right here to build our own MCP server, right? So we're going to just use this instruction. I'm not going to be building anything from scratch. We're going to be using this MCP server. Basically, this is just a weather application that can search can call an API to get the weather information, and then you can ask questions like, maybe what's the weather in the US? It's mostly focuses on US states, so you can ask what's the weather in New York City, what's the weather in California, and all those other places, right? So we're just going to be taking the code right here and then building it on top of it. And the reason why we are going, once you have this built, right, the MCP server built, we're going to go ahead and build on top of it a LangChain agent that can use this MCP server. And you can see how you can use these MCP servers within your LangChain application or your LangGraph application, right? So let's get into it. So I'm going to go ahead and simply copy this right here. Copy this. I'm going to go into my terminal and I'm going to go ahead and make a directory. I'm going to call it MCP server, just like that, and I change directory into my MCP server. So once I'm in there, I'm going to go ahead and paste that command, and that command is going to go ahead and install a UV. I already have UV already installed on my computer, so this should just take a minute to get that done. Okay, so once that's done, you're going to go ahead and then create a basically directory for our project. So it's going to go back in here. You can see I have a UV already installed. So yeah, UV is just a fast Python package manager for installing packages. Runs at crazy speeds. I think it was built with Ruby and in the background. I'm not really sure, but you can confirm that. So once you have done that, you can see you have a folder called for weather, right? So you can name this anything you want, but let's change into that directory. So changing into that directory, and you're going to go ahead and create a UV, a virtual environment. So I'm just going to go ahead and paste that. So once you have the virtual environment created, you're going to go ahead and activate the virtual environment. So I'm going to go a bit faster because it's just mostly copy pasting, and I'm going to leave the link to this in the video description to this specific web page, so that you can also you guys can also follow along. Okay. So once that's done, you're going to go ahead and create a file called weather.py, and this is going to be having our MCP server. Okay. So I'm going to go in here, paste this, and you're going to go ahead and, so if I go ahead and do ls, you should be able to see that weather package file right here. So once I have that, I'm going to go ahead and open my VS Code, or feel free to use any editor that you're comfortable working with. Any IDE works fine. I'm going to be using VS Code, just preference, right? So once I have that done, copied in there, I'm going to go ahead and yeah, we need to copy this code right here. So this is just importing packages and setting the basic MCP server instance. So let me just paste that in here, and I'll explain to you in a minute what it simply does. So open this file and then paste the content in here. So I've just imported the HTTPS, and then you also imported the MCP server instance, the fast MCP. So what this simply helping us to do is just simply, it's going to help us do different things like taking doc strings as a tool description. It's going to help us with all this basic stuff in the background, right? When we talk about how doc strings can be used for, I use actually as tool description. It makes use of the type hints in Python to make tool descriptions very descriptive for AI agents, right? So fast MCP is going to help us. It's a package to help us do that. So we're going to also have some helper function, and this helper function, basically I've read and I've experimented and tried this out. What it simply does is just format the output, right, and format stuff like that. So it's just a utility function. So we paste them in here. And I'm just going to go ahead and also copy this one right here. So implementing this is actually the tools themselves. So I'm going to go ahead and paste the tools here and then explain to you. So we're going to have two main tools. So the first tool is going to be get alert. So gets weather alert from the from a US state, right? So gets weather alerts. That's the first tool. And the second tool, and this is how you define a tool, a synchronous tool, because you're using a sync await here to call that API, right? So you also have the get forecast tool. So we have two main tools: get alert tools that gets weather alerts, and also we have the get forecast, which gets the weather forecast for a different location within the US, right? So once we have that there, we have this we have these two utility functions. Now we can go ahead and actually run our MCP server. So to run our MCP server, I'm going to go down here and then paste this code right here. So this all we need to do, this is just an entry point into our application that runs the MCP server using the standard in output kind of way. We can also use the, if you hover, you can also use the SSE, right? Server side events, I think server side events, something of that. Let me just try to remember. I think it's server side. Let me see, server side sent events, if I'm not mistaken. Okay, let me just check this out. I'm just gonna quick do a quick Google search. I think it's servers. Okay, let me just leave that. Anyone can let us know in the comment section what SSE means. So basically this right here. So that's what I'm trying to say. So SSE, I think it's server side events or server sent. Okay, something of that sort. Yeah. So anyway, that's all we need to do. Now we can go ahead and actually run our code. So to run our code is very simple. So I'm just going to go ahead and show you how to run it. You know what? Let me just go in here and then let's write this out also. So it's say UV run and then weather and then run that. So that's basically, so once you see it's kind of like we don't get back to the normal terminal, that shows that it's running in the background. So now any application on our computer can connect to this MCP server, right? So right now we are running it as simply a standard input output or transport. We can also use the SSE transport, which we'll use later on within the video. Okay, so that's basically you have written our first MCP server. Hey, congrats. Okay, so that was quite quick because we just basically, we just basically copy pasted things from here. So again, this is just for you to understand. Okay, just to lay the foundation. But once you have the code, you can see this is just a normal Python function. So you can write any Python function, right, to perform any kind of operation. Maybe you have your own in-house APIs that you want to call. You can write a tool for that. It's just a normal Python function. So I'm not going to spend a lot of time going into this. So that's basically how you create a simple MCP server. We have these decorators right here that create tools. So that's basically, it's very straightforward and very simple. Okay, so maybe in the future videos we'll sit down and try to write something of our own. Okay, now this is the part which I want us to focus on mainly. So we're going to go ahead and try to create a client. Basically, we're going to create a LangChain agents that's going to be connecting to this MCP client and basically using that. Okay, so let's go back in here. We're just going to go ahead and stop the server a bit, clear the terminal, and I'm going to say UV add, and I'm going to say IPY kernel. So the reason why I'm using IPY kernel or IPY kernel is because I'm going to be using the Jupyter notebook within my code. So I'm going to open this. Okay, sorry, I have that already done. So I'm going to go ahead and create a file. I'm going to call it, basically, you can call it anything that you want to call it. I'm going to say client underscore langchain dot IPY and B. I'm going to be using a notebook. It's just for us to be able to basically interact with this in depth. So let me just keep a heading right here. So I'm going to say, let's make this b2. And I'm going to say MCP langchain client. That's it. And I'm going to go ahead and try to install a couple of things. So I want to say installation. So for the installations part, I'm just going to go ahead in here, change this to be a Python file, just like this, and also change this one to be a Python file as well. So change this to be Python. Sorry, a Python cell, not a Python file. Anyway, so once we have this done, I'm also going to go ahead and okay, you can go back in here and we can just keep on the weather MCP client running or server running. So once we have them, I'm going to go ahead and install a couple of packages right here. So I'm going to say UV add. I'm going to add LangChain. Okay, let me get it. LangChain. Let me get the spelling right. So LangChain MCP adapters. So that's basically, so LangChain MCP adapters, and then run that. Okay, I need to select the environment, right? So I select this, and I'm going to select this environment. Perfect. So once that's selected, we can go ahead and run this cell. Okay, let's give this a bit of time. So, okay, now it's done. So, okay, that's awesome. So it says, okay, so it says I say no solution found when resolving dependency because LangChain MCP was not found. Okay, okay, this I get the spelling there. So it's LangChain, my bad. So let's run this again. Okay, seems to be getting an error. So UV add LangChain MCP server adapters. Okay, today I don't know why I left my spelling mind. Okay, so now we have that installed. Awesome. So once I'm going to go ahead and simply clear this. And once I have it cleared, I'm also going to go ahead and I think I need to install one more package. So I'm going to go back in here and say UV add. I'm going to say LangGraph. I'm going to add LangGraph. I'm going to add LangChain, Anthropic. I'm also going to go ahead and add in Python -.env. So this is going to help us to read our Python environment variables. So we have worked with this already. So once I have this, I'm going to clear this as well. And that's already installed. Okay, once I have all my installations done, we are good to go. So we're also going to go ahead and create a virtual environment file. So the .env, and you're going to say anthropic underscore API underscore key, then equals to, and you're going to go ahead and pass in your anthropic secret key in here. Okay, so let me go ahead and add in my anthropic API key, and I'll be back recording. Okay, so I've went ahead and I've already added in my environment variables already in my instead of my env file .env file, so I can open this time. So I'm just going to go ahead and simply load in my environment variables in here. So I'm going to go ahead and say load envs. Okay, environment variables. In this case, we have only the anthropic API key, and I assume that you already have the anthropic API key. If you don't, just go online and search how to create an anthropic API key. I mean, it's relatively very easy. Right, so I'm going to go ahead and import the following. So I'm going to say from .env, or you can, I think you can check the previous videos. I showed you how to do this using in the videos. Okay, so I'm going to go and say from .env, I'm going to import load env. I'm going to say load env. I'm going to import os. I'm going to say API underscore key is going to be equals to os.environment environ.get. I'm going to go ahead and simply pass in the name that we use, that we specify when creating this under the environment variable. So let me say anthropic -API -key, just like that, and then run this. So that's going to go ahead and load in our environment variable. So once our environment variable is loaded in, you're going to go ahead and bring in a couple of inputs. So just to save time, again, you can find all this on the GitHub right here on the Langflow GitHub. So instead of going ahead and wasting time and typing all this out, I'm just going to go ahead and import this and modify it to our use case. So I'm going to go ahead and copy this, paste it right here. And I'm also going to say from, okay, it's going to be from langgraph and LangChain underscore anthropic. I'm going to import chat anthropic. Okay, so I'm going to import chat anthropic. And we're going to go ahead and create our model. So when we say model, model is going to be equals to, we're going to say chat anthropic, and we're going to go ahead and pass in the model name. So model underscore model, just like this, model, and then equals, and then type in the name of the model. So they have quite a number of anthropic models that you can find. I had, okay, let me see if let me just type this out. I had the anthropic website open up, but just to save time, let me just quickly go ahead and just type it out. So I'm using the Sonnet model, and then it's going to be 2024, and then it's going to be 10th, and then it's going to be 22. So that's the name of the model. And you're going to go ahead and press in API underscore key, and it's going to be API key is going to be equals to sorry, it's going to be API key is going to be equals to, and I'm going to say API key, just like that, and we're going to run that. So that's going to go ahead and simply load in create this, the chat model for us in this case. Awesome. So once we have this chat model created, now let's go back in and let me just go back to my GitHub page, and then I have this already done already. So let me just copy a couple of code right here just to not this. Okay, let me just copy some code here just to save a bit on time, so we don't waste a lot of time there. Again, you can also follow this. I'm going to leave all this link in the description of the video, so if you guys want to refer to it. Okay, so I'm going to go ahead and simply go to this section right here, and I'm going to copy this code right here. So once I have this copied, I'm going to go ahead and place it right here. Okay, so this code is going to be on available on my GitHub page. I'm going to make this repository available to you guys, so you can just follow, right? And so you just go ahead and specify the path to your basically the server, the ACP server file. Specify the path here, and you're going to be using the Python command to run this file. Okay, so I have passed in a message right here. I ask it, what is the current weather in California? The reason why I said California is because it's this weather API that you're using, that the MCP tool is using, is a weather it's basically only supporting the US states, right? Okay, so once I have that, so if you ask if the question about any place other than the US, it wouldn't go through. So make sure that you specify the US. So we have an error right here. It says okay, let me go ahead and say it's okay, just a second. It says not found, means invalid. Okay, I specified the wrong model name. So let me go in here and then make sure I get the right the model name correct. Okay, you can see right here is Cloud 3 Okay, not 3 point. It's actually 3. Then yeah, that's it. And let me run this again. Okay, hopefully I got the name right this time. Okay, so I'm going to go ahead and simply copy this and let's see what you're getting as the agent response. So paste this right here. And once it's done, you just run this and see your this. So this is the agent response right here. So it's difficult to read it this way. So I'm going to go ahead and I have created a utility function that's going to make this much easier to read. So let's just go ahead and let's bring in that utility function to make things much easier to read. So bring in these imports. Once I have those imports, I have this code right here, and it's going to go ahead and make everything much easier to read. So you have the output right here. So you can see this is from the user, which is the user question: what is the current weather in California? And then the AI goes ahead and say, hey, I should first check if this is basically how the AI is thinking, right? So it says that it needs to check the tool and get for any and search for any weather alerts in California. Goes ahead and calls the tool. So these are the tool's operations, and the tools return this data. And then the AI goes ahead uses this data as context, right? The model context protocol. So that's where it all comes in, right? So this agents to the tool execution, which is basically our MCP server, right? So this is coming from our MCP server, right? Providing the context to our model. And this following these protocols, MCP, right? So the agent uses that to go ahead and create the response right here. So there is currently a wind advisory in effect for parts of Siskiyou County. I hope that's the way it's pronounced right. So you can read through it. The whole idea is just to understand how this works, right? I don't really stay in California, so I really know what these counties are, right? So that's basically how you can run this, right? Perfect. Now, this is, you can see we have to wait for this and we get the output in one specific chunk, right? So let's use the SSE approach or SSE transport way, and let's try to stream this content out. So that's basically what we're going to be trying to do. So we go back in here, and then you're going to go in here into our code and then change this to be SSE. Okay, so once we have SSE, I'm going to go ahead and stop the current server, clear the terminal, and let's rerun this again. So as you can see, it's running on localhost at port 0.000, right? All network. And then you can see it's running on port 8000. So we're going to go ahead and make sure we connect our client to port 8000 and we can make a request from there, right? So how do we go ahead doing that? Okay, so I'm going to go ahead and simply do it right here. So I'm just going to add in a markdown just to make our code clean and documented. So I'm going to say using SSE transport, just like that. So once I have this done, I'm going to go in here and I'm going to go ahead and import a couple of things. So I'm going to say from LangChain adapter, MCP adapter dot client. I'm going to go ahead and import the multi server MCP client. Awesome. So once we have that imported, let me close the sidebar so this is much easier to see for you guys. So once I have this, I'm going to go ahead and bring in this piece of code right here and then explain to you what it simply does. So we are connecting to our local host at port 8000 / SSE. This endpoint / SSE, because you are using the SSE transport. Okay, you specify the transport at SSE. Then you ask a question: what is weather in New York City? And let's run this and let's see what we get back. So we should get back agent response. We can pass in the agent response, and then we can bring in this logic we had above here. Copy that, and we try to print it out and see what we get back. So let's run this, and this is the output. So paste this right here and run it. You get back the output. So you can see this is a user's question. What's the weather in New York City? The AI goes ahead. I can help you answer this question for the weather in New York City. I will use the get forecast. Perfect. Chooses the right tool, which is the MCP. Now you can see it uses the MCP server to get the information on weather condition in New York and uses that as context to answer the question. All right. MCP, model, context, protocol, right? And if you go back in, you can see the different requests that our agent is making to the back end, right? Awesome. Okay, now that we have this, now you can see it's coming in one chunk, which I really don't like. So what I want to do is to stream the content. So I have this code that I have written right here. Okay, so I just went ahead, play around with the code, and they're trying to figure out how to make it stream, right? So I went ahead and read the official documentation on the adapters from LangChain, and I have seen how you can stream the content. So we're going to go ahead and say streaming response, and we have this right here. So if I go ahead and run this, we should be able to now to see how we should stream the content each step, right? So you can see this is a question, the AI responds, it goes ahead, it calls the tools, and then finally it's going to go ahead and return to us. It's going to use this as context, and then ahead goes and provide us the answer, right? Awesome. You can see all this is being streamed in live instead of in real time, instead of having to wait for it, right? So you can see streams the user's question, goes ahead and uses the get forecast tool, calls that tool, get a response, and then goes ahead and finally uses the tool's response MCP server. So calls the MCP server, get the weather information. You can see the MCP server is making some API requests to get information. And then once ahead uses that information, which gets formatted and everything, and then it returns back to our agent. So our agent is going to use that as the context. So all this is going to be used as a context to answer our question, original question, which is what is the weather in New York City? So it uses this as context and provides us a final answer, which is this right here. Awesome. So that's basically how the MCP architecture works, and how we can create an agent, basically an agent that's using the MCP architecture using in LangChain, right? So yeah, that's basically how everything works ahead. And you can just see how you can use all these tools. Just really imagine you can use any of these tools right here, and you have access to over 1,300 tools that you can use. Like, it's insane, right? So you can use it to a lot of tools, and it gets following the MCP protocol. You can write your own tools, and in the future, if you want to connect to a different LLM, you can switch a different LLM. If you want to use a different agent, you can just connect this agent to this MCP server. You don't have to rewrite your tools to fine tune it in order to fix the protocols or fix the architecture of the new agent that you're trying to work with. You just have to use an MCP server, connect to the agent, and then boom, off you go. Everything else remains the same. The tool definitions, the tool logic, everything else remains the same. All you have to do is now you take that tool, put it under an MCP server, and you are good to go. It's just like a USB port. You can connect. Basically having a flash drive, right? So once a flash drive supports USB-C, right? So some flash drives do, or having a USB port, right? So you can connect anything into it, right? It's just awesome. Yeah. So I think this is just really, really awesome. And I just wanted to look at it. I just want us to take a look at it before we move into the next tool. So again, you can use this server and you can connect it with your other tools like in Cursor. And let me just show you how many tools it supports. So if I go back into the official documentation, go into clients, it supports a lot of clients. So you can connect this to Cloud Desktop app. You can connect this to Cursor for the coding if you know Cursor. You can connect this to Cursor. I think I have Cursor right here. Cursor. You can connect it to Cursor. You can connect it with a lot of tools, right? The WinSurf editor as well, which is also used for coding as well. So you can write these MCP servers and just connect it within even your coding environment. They can talk to your Slack. So if you go ahead and just go in here, you can search for a tool that can talk to the Gmail and just search. If you search for that, you see we have a tool for Gmail. We have a email servers. We have a tool for Google or Drive. Like, it's really just insane, right? So you can also go in here and just search for a tool for, let me say, let's try to search for a tool that can do let's say a vector store, a vector database, vector store, Quadrant. Let's try to see Quadrant. If there any tool for Quadrant, yes, there are Quadrant tools. Like, it's just insane, right? So there's just so many tools here. I'm just so really excited. Sorry for being so excited, but yeah, it's just really, really crazy how many things you can do with this. I'm just really so excited, and I wish you guys tried using this tool, and then we try to build like many tools as much as possible. I want this website to have all the tools that I need, right? You can just go here, add your own tool. Some of the tools are not perfect. I mean, they are not. I don't think they have any kind of like control in place. I think they need to implement some control so that all the tools are working perfectly, because sometimes they have a bit of issues, right? So it's just crazy how many things you can do. Let's say if you search for Slack, right? Or Slack or Telegram, you should find all these tools right here that you can just use. Like, it's just really, that's crazy. Yeah, so yeah, that's basically it for this video. In the next video, we'll look at human in the loop. And if you're using this MCP servers in cloud desktop app, it will basically ask for confirmation before it uses a tool, because sometimes you can have a tool that can delete things, right? Can delete things on maybe GitHub, or can do different things. So you need a human confirmation. You need to pass this to a human before running some of these tools, right? Because some of these tools can invoke damage. So yeah, that's if you use it within the cloud desktop, it has that feature where it asks you for approval before going on. Maybe you can make a video about that in the next videos, or in the next upcoming videos, right? You can talk about that specifically. Yeah, so we're going to be looking at human in the loop in the next video, and you can see, maybe we can see how we can write our own application to include human in the loop, such that these MCP servers are only called, right? It's asked for which tool to use before going to ahead and using the tool. So the human can confirm, like us. We can confirm, hey, okay, you want to do this, and you will need access this tool for this X and Y reasons. Okay, I allow you to use this tool. Let's say that you want to send an email, right? You don't want the AI system to be sending emails to just anyone, right? So it needs to pass this to a human. Okay, I want to send email to John Doe, and then be like, okay, fine, go ahead and use the email sending tool, right? So we need that kind of control in place. And that's we're looking at human in the loop. We'll start looking at the foundation of human in the loop in the next video. So guys, thank you so much for watching, and I hope you found this really helpful. Again, you can connect with me on LinkedIn. Uh, on LinkedIn at Prince Crumper. You can find me on X, aka Twitter, at Prince_Crumper. On YouTube, you can find me on Code with Prince. Hopefully, you're watching this video. On Medium, you can find me. I write articles about this stuff as well. So if you go to Medium and you try to look for me on Medium, again, you also find me on Medium as well. So if I go back in here, this is me on Medium right here, Prince Crumper, right? Prince Crumper on Medium. And I also have this MCP. I have written an article about it. I have not yet published it, but I'll publish it and I'll leave the link. So you can just go on LinkedIn, search for Prince Crumper. So for those of us who like reading, and you can always read instead of watching the video. Okay. So I have all this written down in more, even much depth. Okay. Yeah, so guys, thank you so much for watching. Again, if you find this content helpful and you want to support the channel, the easiest way you can do that is simply by liking this video, sharing this video with your friends and family who you think might find this helpful, right? So drop a like, subscribe to the YouTube channel, share this video with your friends and family or colleagues who are interested in such field. Again, if you also want us to connect or connect with me, you can find me on LinkedIn. I'm much faster to respond to you on LinkedIn. So if you have any project, any ideas, any suggestions, you can always follow me on LinkedIn. And if you want to support me further, you can buy me coffee. The link to buy me coffee is going to be in the description of the video, right? So guys, thank you so much for watching, and see you in the next video. Keep safe.